Video we will be covering 8B unions and intersections. So let's have a look at set notation first. A set is a collection or group of elements that can include numbers, letters, or other objects. A sample space, denoted by this capital S, omega, this U, or xi, is the set of all possible elements or objects considered in a particular situation. This is what we refer to as the universal set. So to represent unions and intersections, we can use a Venn diagram, which can illustrate how all elements in the sample space are distributed among the events. So in this first diagram here, we have a Venn diagram showing all elements of A in this circle. This A dash is all elements that are not included in A. Or we have two circles here. So one circle represents A, one represents B. This middle section, which I've highlighted in blue, represents the intersect, okay, or the intersection between A and B. Once again, A dash represents everything that is not A. A null or empty set is a set with no elements, and it is either symbolized by brackets or the null sign symbol. All elements that belong to both A and B make up the intersection, which is the upside down U. All elements that belong to either events A or B make up the union. So two sets A and B are mutually exclusive if they have no elements in common. So this means that the intersection between A and B must equal to the null set. For the event A, the complement of A is A dash, or in other words, not A. Okay, so that's what we refer to as the complement. Another important concept, the probability of the complement of A, or the event that A doesn't happen, is 1 minus the probability of A. A only is defined as the elements in A, but not in any other set. N bracket A is the number of elements in set A. So it's the number of elements in set A. Finally, let's have a look at these Venn diagrams. So Venn diagrams and two-way tables are useful tools when we consider two or more events. So in this first section here, this is what we have with A only. So just 3. This one here, we have the intersect between A and B. This one here is only B. And finally, this one here is going to be neither A or B. Now looking at a two-way table, we can represent similar information. So with this box here, this is going to be everything that is A and B, or the intersect. This is going to be everything that is only going to be B. This is going to be everything that is only going to be A. This is going to be everything that is neither A or B. And finally, going across, we have everything that is a total elements in A, total elements of everything that is not A, total elements of B, and total elements of everything not B. Okay, let's try some of these examples ourselves. First one, consider the given elements A and B that involve numbers taken from the first 10 positive integers. So in the set of A, we've got 2, 3, 4, 5, 6, 7, 8, and in the set of B, we've got 1, 2, 3, 4, 5, 7. Represent the two events A and B in a Venn diagram showing the number of elements belonging to each region. So, to start off our Venn diagram, I would first draw a box, followed by two circles representing A and the other one representing B. So from our sets, let me get this highlighter, we need to ask ourselves, how many elements do A and B have in common? So for A and B, there are 2. They both have 3. and they both have 5, and they both have 7. So that's a total of 4 elements which are common between both. So let's have a look at the unique elements which are unique to A. So we've got 4, 6, and 8. So that means in my box of A, we will have 3. And the elements unique to B are just going to be 1. So that's just going to be 1. Now remember, the questions asked us from the first 10 positive integers. So that means we're missing the numbers 9 and 10. So that means that everything that doesn't belong will be 9 and 10. So that'll be 2 remaining. So for part B, this is asking us list the following sets. So for BI, we have list A intersect B. Well, this will be what they have in common in this region that I've shaded. So we worked out before, this will be open bracket for the list 2, 3, 5, and 7. So that's what they both have in the intersection. 4 elements, these are your 4 numbers. So for BII, this is asking us to find A union B. So in other words, what do they have combined between both of them without overlapping? So you open the list, open the bracket, and we get 1, 2, 3, 4, 5, 6, 7, and 8. For question CI, this is asking us if the number from the first 10 positive integers is randomly selected, find the probability that the following events occur. So the probability of obtaining, or the event of A happening. So in this case, ask yourself, how many elements do we have? We have 3 plus 4 in this circle of A. So that's going to be 7 over 10. In CII, we are given the probability of A intersect B. So this will be 4 elements over 10, because we have 4 in the middle in the intersection. And you can simplify that to 2 over 5. In example CIII, this is asking us to find the probability of the union with B, A and B. So this will be how many elements we have in total between A and B. So we've got 3 plus 4 plus 1, which will give me 8 over 10, which we can simplify to 4 over 5. And finally, for D, this question is asking us, are the events A and B mutually exclusive? So the answer to this one will be no. The reason why is because A intersect with B does not equal to the null set. So this was one of our rules. Okay, let's continue moving on. From a pack of 20 dogs, 9 enjoy fish meat, capital M, 12 enjoy dry food, capital D, and 7 enjoy both fresh meat and dry food. So part A is asking us to illustrate this information in a Venn diagram. So once again, you want to start your Venn diagram by drawing 2 circles, followed by a box. So we know we've got 2, in this case, 1 is M, and 1 is D. They've told you that 7 enjoy both fresh meat and dry food. So that means that we will put a 7 in the middle here. They've also told you that 9 enjoy fresh meat. So this circle here with the M circle must add up to 9. So 9 minus 7 will give me 2. And they've also told you that 12 enjoy dry food. So this box here, sorry, should I say this circle here, should add up to 12. So 12 minus 7 will give me 5. Now all these numbers must add up to 20. So the missing number must be 6, which goes on the outside. Okay, in part B. So BI is asking us, state the number of dogs who enjoy fresh meat only. So for dogs that enjoy fresh meat only, this will be just the 2. Okay. State the number of dogs who enjoy neither fresh meat nor dry food. So neither fresh meat nor dry food, this will be 6, because they don't belong in any of them. In part CI, we are asked, find the probability that a dog chosen at random from the pack will enjoy fresh meat. So the probability of fresh meat will equal to 2 plus 7, which will give me 9, over a total of 20. Okay, so for CII, this is asking us to find the probability that a dog chosen at random from the pack will enjoy dry food only. So for dry food only, this is going to be probability of D only, which will give us 5 over 20. We can simplify this to a 1 over 4. In CIII, this is asking us both fresh meat and dry food. So the probability of fresh meat and dry food is going to be M intersect D, which will be 7 over 20. Okay, let's move on to the next example. The Venn diagram shows the distribution of elements in 2 sets, A and B. So we've got A, B, the intersect, and the box outside. So part A is asking us, transfer the information in the diagram to a two-way table. Okay, so to draw one of these, we would start off by doing this. So excuse the messy diagram. And you want 2 boxes here. Let's go across here. Let's go across here. And we'll split it down in the middle here. So this is going to be A dash, so everything not A. This is going to be B. This is going to be B dash, so everything not B. Part A, we want to represent this as a two-way table. This Venn diagram as a two-way table. So A and B, we can see that they've got 2 elements in there between the intersect. Now everything that is not A, but B, so only B, this is going to be 3. If we go across, everything that is A and not B will be 4. Everything that is not B or not A will be 1. So now we can fill in our total. So the totals going from 2 to 4 will give us 6, 3 to 1 will give us 4, 2 to 3 will give us 5, 4 to 1 will also give us 5, and we'll notice very quickly that both of them across and this way will give us 10. So if these numbers match up, so 5 and 5 are 10, 6 and 4 are 10, you know we've done it correctly. So let's have a look at BI. So this one is asking us to find the number of elements between A intersecting B. This is just going to be 2. So for II, this is going to be the number of elements not including A intersecting with B. So in other words, only B, this will be 3. Oh, let me get my black pen. That'll be 3. In III, we know this is going to be the number of elements which intersect A and not B, so only A. This will equal to 4. In IV, this is asking us the number of elements that are not A intersecting with everything that is not B, so this will just be 1. In V, this is asking us the number of elements in A, so that's going to be 6. VI is asking us the number of elements which are not B, So everything that is not B is going to be 5. So where we get 5 from is there's going to be 4 plus 1, which will give us 5. In VII, this is asking us the number of elements with A in union with B. So in total, there should be 9. So that'll be 4 plus 2 plus 3, which will give us 9. Okay, let's move on to part C. So CI is asking us for the probability of A intersecting with B. So this will be A intersecting with B. So this will be 2 over our total, which will be 10, which simplifies to 1 over 5. In part CII, this is asking us for the probability that everything that is not A, and that's going to be equivalent to 3 plus 1, which is not A, so that'll give us 4 out of 10. We can simplify this to 2 over 5. And finally, the last question, we have CII, which will be the probability that we have A intersecting B with everything that is not B. So in other words, everything that is just A. That's going to be 4 over 10, which we can simplify to 2 over 5. Alright, so that's it for this video. Hopefully you found it useful, and I'll see you on the next one.